Hey folks, and welcome to our next video. We're going to be taking a look at how do we write polyatomic ionic compounds, both writing names from formulas and writing formulas from names. So just as a recap, remember ionic compounds are compounds that are formed when a metal gives electrons to a nonmetal. And remember that this transfer of electrons creates positive and negative ions, and they attract to each other because opposite charges attract. And what you've been working on the last couple days is how do you write ionic compound names and how do you write ionic compound formulas. Those rules are still going to generally apply here in what we're going to talk about today, but we're going to be adding on polyatomic ions. What are polyatomic ions? Well, these are ions that are a group of atoms that are bound together, so they're all stuck together, and the group as a whole has a charge. When we've talked about ions in the past, that's just been single elements that have a charge. Here, this whole group of elements, right? So for example, our nitrate group over here or our sulfate group over here, right? These are going to all act as one unit and they all have a charge. So for example, the nitrate group has one negative charge. The sulfate group has two negative charges, okay? Now, polyatomic ions are part of ionic compounds. They will not be found in any molecular compounds. These will only be found in ionic compounds, and that's because they have the charge here, right? And so that charge means that they're going to be attracted to other elements. What are the polyatomic ions that you need to know? Well, here's our list, right? So this is the list that you need to have. You don't have to memorize this. You can just copy it down into your notes. So make sure that you pause the video and write these down and use those whenever you need. Now, when you're looking at your polyatomic ions, we have a formula and then we have a special name. Notice that these names don't necessarily relate exactly one-to-one with the elements that are involved, right? So ammonium is nitrogen and hydrogen. And it's specifically 4 hydrogens. If that said NH3, that would not be ammonium. Okay, ammonium is only NH4. Same thing for nitrate. Nitrate is 1 nitrogen and 3 oxygens, and they all act as a unit. They're all as a group. Okay. Now, when you're looking at this, right, the elements, that's the PO, and then the 4 is telling you that there are 4 oxygens. The charge is right here, okay? And that's going to tell you what you need to know when we start to write the formulas, very similar to when you were writing formulas for ionic compounds, right? Where you had like potassium with a +1 charge, chlorine with a -1 charge. That charge here is going to be important for figuring out how to write the formulas. So again, make sure you write down this list. That way you can always come back and reference it. Now, how do we go about writing the names of compounds with polyatomic ions? Well, very similar to how we write other ionic compounds. Okay, we're going to use the same rules, except we don't add IDE to the end of the polyatomic ions. So our polyatomic ions, they have specific names, right? Hydroxide, carbonate, sulfate. Those we do not add IDE to the end. Those are their specific names. So, for example, if we have KNO3, we got to look at our periodic table and we got to look at our list of polyatomic ions. K is potassium, NO3 is nitrate. Okay, so we've got potassium and nitrate, and all we're going to do is stick those together. Potassium, nitrate. Remember, the metal always goes first. And really, if you're looking at a formula, whatever the order is, you just are going to say that in the order of the formula. You're just going to put them in that same order. Except, second example, we got MgSO4. Mg is magnesium. SO4, we got to look at our list, is sulfate. So this would be magnesium sulfate. Very easy, right? Now, it is possible for you to have a polyatomic ion first or to have multiple polyatomic ions. So, for example, ammonium is a polyatomic ion that will often appear first. So, like, let's say we had ammonium and then we had chlorine, right? That would be ammonium chloride. So you still have to add the IDE to the second nonmetal if it's not a polyatomic ion, right? But again, the polyatomic ions, you don't add IDE. Now, let's take a look at the slightly trickier part of this, which is writing formulas for polyatomic ion compounds, right? So just like with other ionic compounds, it's a little bit harder to write the formulas than it is to write the names for ionic compounds. So, but the process is going to be the same. We're still going to be using that crisscross method. So let's take a look at our first example, which is lithium and carbonate. So carbonate, we got to look at our polyatomic ion list. One thing that can kind of help with that is whenever you see the ATE ending, that's always going to be a polyatomic ion. So you can always know that. There are a few others that don't have the ATE ending, but that's always a really good indicator that you need to go to your polyatomic ion list. So lithium, we know the symbol is Li, and carbonate is CO3. And you'll notice that I've added on our charges or our oxidation numbers here. You want to go ahead and write those down when you're identifying these, because we got to do our crisscross method just like we did with the ionic compounds. So we're going to write our lithium and our carbonate, and we're going to crisscross the charges, right? So the 1 is going to come outside of the CO3, the 2 is going to come down out to the lithium, right? They're going to crisscross just like that. And remember that if you've got a 1, you don't need to write it, so we're just going to drop that, and that becomes Li2CO3. And what this does is this makes this a neutral compound, right? So we've added, we've got 2 lithiums, right? They each have a +2 charge, and we've got the carbonate, which has a -2 charge, +2 -2. That gives us 0. That's what we're looking for. Crisscross method is just our shortcut for that, all right? So we've got Li2CO3. This would be lithium carbonate. Let's take a look at a couple more examples. All right, we've got magnesium hydroxide. So hydroxide, that's not hydrogen and it's not oxygen. It's hydroxide. It's a polyatomic ion. So you got to look at your list. So we've got magnesium, which has a +2 charge because it is in group 2A. And then we've got hydroxide with that -1 charge. Now, same idea. We're going to write those two next to each other. And again, we're going to be crisscrossing here, okay? But when we crisscross here, it's a little bit different. Because this is a polyatomic ion, this OH is a group, okay? So it would be incorrect to just put the 2 on the outside here, because what this is saying is that we have 2 hydrogens, not that we have 2 hydroxides. So the correct way to do this is to add in parentheses around the polyatomic ion. Okay, so we add parentheses here around the polyatomic ion, and that shows us that this is not just 2 hydrogens, it's now 2 of the whole thing. It's kind of like when you have parentheses in a math equation, when you put like a 2 out in front, how you have to multiply that 2 across everything. It's a similar idea here. We just write it as a subscript because it's a chemical formula. All right, let's look at one more example where we have 2 polyatomic ions, okay? And of course, I've got my arrows on there a little bit out of order, but that's okay. Let's do ammonium hydroxide, okay? So I've got ammonium, which is NH4, hydroxide, which is OH. I'm going to write those 2 down. There's my ammonium, there's my hydroxide. We're going to be crisscrossing, but again, these are 1s, right? We don't have to write 1s, so those will get dropped, and I don't have to put anything. If I had a 2 in here, right, I would need to make sure I put parentheses, and when you put the parentheses around something like the ammonium or the sulfate, they've got to go around the whole thing, okay? So anyways, that's how you write and name polyatomic ions. You got a little bit of practice to do, and thanks for watching, and I'll see you next time.